Hi, it's Carly McAvoy. I'm talking about changing between radical notation, rational exponents, and decimal values. And in this video, we're going to work through these 4 examples starting that are in radical notation. Then we'll do 3 examples where we're in rational exponent form first and going back. So when I talk about a radical, I am going to be talking about the number underneath is the radicand. The symbol is the radical, and then the index is r. When we have an index of 2, we don't usually show it. So when I see the square root of 5, I know that the index is 2, even though it's not there. But that's what it is. In this case, the index is 2, and the power of the radicand is 1. So what we're going to be doing is we're going to rewrite the radical notation by putting the power of the radicand over the index. And the base is still the base. So the index is 2 and the power is 1. So that's going to look like 5 to the 1/2. The power underneath here is 1 and the index is 2. That's how we get 1/2. And then we know that you can put either form into your calculator. The square root of 5 we now know is the same as 5 to the 1/2 power, and that's going to be a decimal equivalent rounded to 2 places of 2.24. You can, when you put a square root into your calculator, it might, like if you put some calculators, you put the square root of 5 in, it's going to just give you back square root of 5 because that's the most simplified form of that radical. But if you want the decimal, this is a little tip, you just put the decimal point after the 5 and it'll give you the decimal equivalent back. But you can also enter 5 to the 1/2 power and get the same answer. You might want to try doing both. Okay, for number 2, we have this cubic root, so our index is 3, and 10 to the 2nd power. So the index is 3 and the power of the radicand is 2. And remember, our base is the base. So it's still 10 out here, and the power underneath there goes to the numerator, and the denominator is from the index. So now we know that the 10 to the 2nd power, the cubic root of that is the same as 10 to the 2/3 power. Put that into your calculator and you'll get approximately 4.64 rounded. Another example, when we have no index showing, we know that the index is 2. And it turns out the power of this radicand is also 2. So what happens when our index and our power match? Well, we have 2 over 2. And what does 2 over 2 equal? It equals 1. So the square root of 3 squared is 2 over 2, which is just 3 to the 1st power, or 3. And as you work with radicals, you'll see if the power under the radical matches the index, those two things cancel each other out in this way. So they become 1, right? Our last example is if you have 6 to the 7th power and you have the 5th root of that, then the index is 5 and the power of that radicand is 7. So to rewrite that, we would keep the base, and the power underneath here becomes our numerator, and the index becomes our denominator. And so we can see that those two ways to write it, they equal the same thing. They both equal approximately 12.29. You can put it into your calculator either way. If you were going to put this into your calculator and you don't know how to do it, I have videos about that, but let me know if you'd like to see a video on how you would do that in a calculator. It's harder on a phone calculator, but if you have a Casio or TI or whatever you have, you should be able to do that on your calculator. Some people find it easier just to enter it this way. Okay, what if you're going the other way and you had exponent notation? When we're talking about rational exponents, it just means that some of your exponents could be fractions. And so we talk about those as rationals. If you're going the other way, then you would say the base is still going to be the base, as we saw up here. And the numerator is going to be the power of that base, and the denominator is going to become the index. So 6 to the 7/4 power, the base is going to be 6. The numerator is 7 and the denominator is 4. So when I put that back under there, I'm going to have 6 to the 7th power, and that denominator 4 is going to be my index. Once again, you can put it into your calculator in either form. That comes out to be approximately 23. Going on for the last 2 examples, 12 to the 1/2 power. Again, when we see 1/2 power, that index is 2. And so we know when we do that, that we don't have to show a 2 because we assume that that's an index of 2 unless we put a different number in there. The other thing is the numerator is 1. We don't need to show a power of 1 because we assume every number is to the first power unless we state differently. So that's just plain old square root of 12. And then the square root of 12 is the same as 12 to the 1/2, and that's approximately 3.46 as a decimal. And the last one, we have a base of 18. We have a numerator of 2. We have a denominator of 9. That denominator is going to be our index, and the 2 is going to be the power of underneath the radical. So that's 18 to the second power. Index is 9, and if you rewrite those are equivalent. Put those into your calculator, you should get about 1.90. So if you've just been passively watching, grab your calculator and make sure that you can get those answers on your calculator because you'll be asked to do that in class. Have a fantastic day. We'll see you next time.